Any idea to how to approach this question? Student.
Okay, who are answering in messages, you can always speak up. Okay, because it's very difficult to give the I mean, look at the messages and then check the slides and all that. Okay, so if you have something to say, you please turn on your mic and then you can talk about it. Okay, I can see some messages that are coming.
Uh, Anirudh, your answer is correct. Can you tell us how did you reach to that answer?
Yes, sir. So they said that we require successive visits with round trip time RTT1 and RTT2 and so on till RTTN. We know that DNS lookup runs on UDP, so directly, like I'll send one message requesting and one more message with the answer. So that will be one round trip time, and that will happen for each successive visit. But while once I get the IP address, then I need a TCP connection in order to get the uh, object that is requested. For that, I'll need two round trip time, one to establish the TCP connection and one to get the object.
That is absolutely correct.
Any other student? Only Anuruddh is given answer. Any other student? Karthik Verma. You solve this question? Karthik Verma. Nikhil Kumar Pandey. Okay. Then I will explain how to approach this type of question. See here, first step is this is your computer. Okay, in that is your client, and you want to type some web address, that is www.xyz. This is the first step. Then based on the question, you first um, look in the local cache. There is no IP address, then you have to go the DNS. There is in question they are given the NDNS is there. Okay, before you are getting IP address of the particular web. Okay, this is the scenario. And after that NDNS, you will get the IP address. Okay, that is second step. And third step, based on that IP address, you are connecting the TCP connection with the web server. Okay, and based on that you are getting the web pages. This is the three step model. Now uh, the next is how that answer is come like that. First, this one is RTT one. You have to go first DNS, then RTT two for DNS two, and there is a NRTT means there is RTTN, and there after you are getting that um, analyzing the NDNS, you get the IP address. Based on the IP address, you are connecting to the web server. That is RTT0 for the connection, and again RTT0 for the web pages. There is a similar type of distance. That's why RTT0 is we are taking like this. The total amount of time to get IP address is RTT1, RTT2 plus RTTN. There is a, after that we get IP address. Based on that IP address, RTT0 elapses to set up the TCP connection, and another RTT0 elapses to request and receive the small, that is that HTML, that object. The total response time is 2 RTT0 plus whatever time taken to get the IP address. This is answer. If you have any doubt in answer, okay, then fine. Then there is a next question. I will give 5 minutes for this second question solving purpose. You use that first problem, refer that first problem. Suppose the HTML file refers the 8 very small object on the same server, neglecting transmission time. How much time elapses with? Now there is the first option is not non-persistent HTTP they are used, and there is no parallel TCP connection. Okay, and second is persistent HTTP with browser configuration of 5 parallel connection, and C part is a persistent HTTP. Can you tell me what is that persistent HTTP connection and non-persistent HTTP connection? Anyone?
Sir, in persistent HTTP connection, we only do the setup once, and then all the objects, for every object we just send a request message and get the answer back. But in non-persistent, every object is enclosed in its own message, so you have to set up connection for each and every object that you have requested.
Good, good, good. Okay, for every object we have to, in non-persistent we have to connect new connection for the every particular object. Okay, in persistent connection only one connection is sufficient. Now you can try to solve this question. I will show that first based on this diagram you try to solve.
Pratnesh Prasad, have a question. Nirud, please explain how did you come answer?
Sir, for it's the same to get the IP address until that step, it will be same as the previous one only. So RTT1 plus RTT2 plus so on, RTTN plus 2 RTT0 will be the same as the previous one in order to get the first object. And then the first object will reference 8 objects, and for each we have to set up connection and then get that object back. So then you will need 8 into 2 RTT0. So 16 plus 2 becomes 18.
Okay.
Okay.
Does
Any other student?
Sas,
Hello, sir.
Huh?
Sir, for the first time, we'll require RTT1 plus RTT2 plus 2 RTT0. After that, we already know the IP address, so it will only take, like, it will not take this thing again. So only one RTT0 will be required for each of the subsequent objects. So it will be 2 into RTT0 for the first objects plus 7 RTT0.
Okay. Any other answer?
Shubham Shankar, how did you come with that answer?
Sir, to determine the IP address, the DNS lookup time is RTT1 plus RTT2 plus so on till RTTN. And then we could get the HTML file. For getting the HTML file, you'd have to establish one TCP connection. So that would require 2 RTT0 time. And after which, since we have 5, we can maintain 5 parallel
Okay,
TCP
you are in
connections.
part B, right? I'm sorry.
Yeah.
Let's go clarify that. Does anybody have any other answer for part A?
Any other answer than part A? Any other answer, different answer? Ishan, mathematics department, Ishan. You solve this question? Ishan.
Sorry, sir, I just joined the class.
Oh,
Uh,
just read the question. Oh, wait. Shashwat Mishra. You got this question. If you have any doubt, then ask me. Because
Yes,
this
sir, I
question,
answered.
you answered.
Yes, sir. Mine was like RTT1 till RTTN for some, and for this, like for the first object, it will be 2 RTT0, and for each of the remaining 7, it would be 1 RTT. So 2 plus 7, so 9 RTT0s.
Okay, this is for question that is
A.
subpart is A.
Yes, sir.
I mean that is a 7 RTT1 plus RTT2 plus RTTN plus 7 RTT0. Your answer is
No, plus 9 RTT0.
plus 9.
Yes, sir.
Okay.
Okay.
Any other answer? See this question,
Sir, I
this
have a
type of.
doubt.
Okay,
Sir,
okay. Tell me.
Sir, do we have the HTML file beforehand, or we have to fetch that as well?
No,
Like,
it's in your hand.
then
We
the
have to
answer
fetch that.
should be only 16 RTT0.
No, we have to fetch that. After
Okay.
you fetch the HTML file, only then from the HTML file will you be able to
Okay.
get
Okay.
the remaining.
Fine. If we have to fetch that as well, then the answer would be what Anirudh said: 18 RTT0 plus summation RTTI.
Yes.
Okay, I want to clarify something. So in this question, we have been told that there are 8 very small objects on the same server, right? But to get those 8 very small objects, first we need to have the HTML file. So actually, in actuality, 9 objects. First we get the HTML file, that is done separately. Then from the HTML file we get the other 8 objects. Okay, so should be clear.
Sir, your volume is very less, like you were not audible.
Can you hear me now?
Huh.
Okay. What I'm saying is, in the question says that there are 8 very small objects, right? But in actuality, there are 9 when you include the HTML file as well. But what happens is, when you first get the HTML file, only then it references the remaining 8 objects. So that should be clear. First of all, the connection is created and we get the HTML file. And that HTML file references other 8 objects. So total there are 9 objects if you include the HTML file. Is that clear?
That is completely problem number 1 you are referring. Means this one.
Yes, yes.
2 RTT0 plus RTT1, RTT2 plus RTTN. This is the answer of the first. Based on that, you have to answer the that is the next question.
Isan, Rehan, do you have something to say?
Sir, my network got disconnected while I was speaking. So
Yes. Please continue.
I had to read the question. I'm not sure what my name was called in the class. Right.
Okay, no problem. So you were able to do the first question, right?
Sir, I don't know the question.
Okay. We'll go back to the question number 1 once. Please have a look.
Okay. Then there is another question. In that persistent HTTP, there is no parallelism is there. Okay, no pipelining is there. Then what is the answer?
Sir, it would be RTT1 plus RTT2 plus RTTN plus 10 times RTT0.
Yes, that's good.
Because up to 2 RTT0, we would be fetching like RTT1 plus RTT2 plus RTTN plus 2 RTT0. We would be getting the HTML file. And after that, we have to fetch the 8 objects.
So are you saying for non-persistent?
See, sir, persistent HTTP.
Okay.
Then, as it is persistent HTTP, then we don't need not to create establish connection every time. As it is established for the first time, we can send it in the same connection. So it would take 8 RTTs.
Okay.
So total it would be 10 RTT.
Okay, good. Now this is answer. That first answer is 18 RTT0 plus RTT1 plus RTTN. The first answer. And second answer is that is 6 RTT0 RTT plus RTT1 plus RTTN. In persistent there is a 3 RTT and last one is 10 RTT 0 plus RTT1 plus RTTN. Okay. Now,
Sir, excuse me. So once we fetch the HTTP, don't we need to process that to get the list of the objects to fetch from the server before?
Yes. We need to, but we are not considering that right now. So we are just considering the network thing. So what actually happens? Yes. Please say.
So if we process that, don't we need to establish a new persistent HTTP connection to fetch the 8 new objects that we got
Okay.
from the HTTP?
Okay, we'll discuss each and every one separately. Okay. For the first one, let's say non-persistent HTTP with no parallel TCP connections. That is question number A. What we need to do is first we get the IP address, and that takes RTT1 plus RTT2 up to RTTN. That is clear?
Yes.
Okay. So after that, what we need to do is we need to get the first HTML object. For that, we need to create a network. I mean, like we need to start. We need to start the network, establish the network. Okay. So that one establishment takes RTT0. Okay. The whole establishment, the request and response, the whole thing. And after that, we will fetch the HTTP HTML file that is text. So that getting that also takes exactly RTT0. So we already have two RTT0 for to get just the HTTP is first setting up the HTML file. Okay. So far our question number 1 part is done. So now what happens? There are 8 very small objects that are on the HTML file. So for each and every one of those 8 files, we will need to create a single connection for each and every, since there is no parallelism, so we'll have to do it one after another. So first we will take a single object and then we'll create a connection for that, and then we'll request response the first object. So a single object takes 2 RTT0. Is that clear?
Yes, sir.
Okay, so there are 8 objects, so each taking 2. So 8 into 2, so 16 RTT0s are for just fetching the objects, and 2 RTT0 was for fetching the HTML file. So a total of 18 RTT0s are required for fetching the objects, and RTT1 plus RTT2 up to RTTN to get the IP address. So the total time for non-persistent HTTP will be 18 RTT0 plus 1 RTT1 plus RTT2 up to RTTN. Is it clear?
Yes, sir. Yes, sir. Actually, my doubt was in part C, sir. Like,
okay, part C. See, in part C, there actually we have divided it into 2 subdivisions. Persistent HTTP with no parallel, and persistent HTTP when the parallel limit, there is no parallel limit. That's not for 5, but infinite parallelism is allowed. So, okay. So, sir, next, go to the next. So here you can see in C, persistent HTTP. What is happening is we are requiring 2 RTT0s just to fetch the HTML file, right? And a single RTT0 to get all the remaining 8 objects. Is that clear?
Yes.
Yeah. Part
like
C is yes.
If there's no parallelism, so
okay,
first
that
I
is
fetch.
part 4.
Yeah.
Yeah.
So if we fetch the HTTP file first,
yes.
Then we need to process the objects that we need to fetch from the server.
Yes.
So during that time, does the persistent HTTP connection remains open?
Yes, it remains open.
Okay, sir. Thank you.
Is that clear? Does that make it clear?
Yes, sir, yes, it does.
Any doubt?
Excuse me, sir.
Yes.
Sir, in part 3, I had a doubt. Why is it 3 RTT0?
Say.
What I thought was that 2 RTT0 would be required to fetch the HTML file, and then 1 RTT0 to get 5 objects parallelly, and then 1 RTT0 to get 3 objects.
This is not for 5 parallel connections. If you do for 5 parallel connections, then that would be 4 RTT0. Here we are considering infinite parallelism. So if you consider 5 parallel connections, then it will be 4 RTT0. That is correct.
Okay.
That is the default mode of HTTP in persistent.
So if there is pipelining, then you mean to say that okay, theoretically we'll take infinite objects will come together. All the objects would be coming together.
Yes.
Yes.
That take only 1 RTT0.
we can take a limit on the number of parallel connections as well. But here we are just assuming that there is no limit. That's why we are getting 3 RTT zeros.
Okay, sir. Thank you, sir.
Okay. So can we move to the next question? Are there any doubts?
Sure, you can start.
Is the slide visible?
Yes, it's visible.
Okay. Please, this is a continuation of the same question that was asked before, but now with values. We are not fetching the IP address. Now we are just considering the objects of the HTML file. So please go through the question. If you have any doubts, please let me know. And now we'll approach this question in a slightly simpler way. So you have 5 minutes. Please try to get the answers. If you have any answers, please speak up. You don't have to write in the text, chat box. If anyone has any doubts regarding the question, please feel free to ask.
So no one has any doubts on the question? If that's not there, then Saurav, you can carry on.
Okay, ma'am. So let us just write down whatever has been stated in the question so far. So one data packet is of 10 to the power 5 or 1 lakh bits. One control packet is of 200 bits. So if there are n parallel connections, then each connection's transmission rate will be 1 by n into the total bandwidth. So each object is of 100 kilobits, which is equal to, again, 10 to the power 5 bits, which is equal to the packet size. And we know that the initial HTTP text object has 10 references. Also, let us assume that TP equal to propagation delay. This is only one-way propagation delay. Okay, so these are what has been already mentioned in the question. So how do we go ahead with this? So first, what we'll do, we'll first create a connection. So creating the connection, first we'll send a request and we'll get a response. So connection establishment. So what we are sending 200 bits of data for control over the speed of 150, and it is taking TP to be transmitted to reach the server, and we are getting a response from there with the same bandwidth 200 bits divided by 150 plus TP, which is propagation time. So this much time is required just for connection establishment. So after that, we fetch the HTML object. So to fetch, we will first send a request. So that is also a control message which will take 200 divided by 150, the same thing as above plus the propagation time. And since the HTML text object size is 10 to propagation time. Once we have the HTML object, from the HTML object, we can see that there are 10 other objects that need to be fetched. So we need 10 connections for 10 reference objects. So the speed of each will be reduced by 10. That is, let n equal to 10 here, as stated in the question. So for control, each one will have bandwidth of 150 by 10. That is only 15. And they have to send 200 bits for control, including the propagation time, that is TP. And these connections will be made for all of them. So 200 divided by 150 by 10 plus TP for the response time. Once the connection has been created, now we need to fetch each and every object. So fetching the object will also take, we need to send a request. The request is of again 200 bits, so it will take the same time as above, but the response that we get will have files, each of size 100,000 or 1 lakh bits. That will take 100,000 by 150 by 10, that is 15 plus propagation time. So once the objects are fetched, so we can add them all and we get this. So let us get the solution, that is 7,377 seconds plus 8 times of the propagation time. So this is what we are getting. Now let us consider a persistent HTTP connection. So what will we have to do for that? So considering the same process, we can see is first we need to create a connection. So this part will be for the connection. And after that, we will get the HTML file. So this part is for the HTML file that we get. Now we need 10 connections. So since here we don't need to create connections for each and every one, the first initial connection is fine. So we'll just have to send 10 times the control packet to request and 10 times the file objects that we are receiving. So that is the total amount, and we are getting 7,351 plus 24 times TP, which is very close. So if we assume the speed of light to be 300 into 10 power 6 or 3 into 10 power 8 meter per second, then the propagation time will be 10 because it is a 10 meter link divided by the value speed of light, which is equal to 0.03 microsecond, which is very tiny considering 7,377 seconds. So in this case, we can see that the persistent HTTP is not very much significantly faster or slower than the non-persistent case with parallel downloads. Does anybody have any doubt regarding this question? Am I audible?
Yes, sir.
Yes.
Sir, can you come to the previous slide? I want to ask one thing.
Sure. 1 second. This one?
Yes. When we are fetching the HTML text object, then
Yes.
when the client is requesting the server, we are sending an acknowledgement packet, so 200 bits for that. So one way it's fine. When the server is responding with the packet, that is 10 raised to 5 bits, why are we not also including the 200-bit acknowledgement packets? Like, shouldn't it be 10 raised to 5 plus 200 divided by 150?
The server is not sending the acknowledgement packet, it's sending just a data file. The data file itself. Why do I did not get it? Do we need an acknowledgement for that? We can just sends the data packet, right? Not the control packet for that. When you request a server something, you'll just send whatever is requested, not an acknowledgement along with that.
So when we are in establishing a connection, then the server will respond with the control packet as well. But
Yes.
when we are fetching some object, then
yes.
Only the fetching
Check
requested object will be returned and not
yes,
the
that is correct. Yes, that is absolutely correct.
Right.
Any other queries, anybody? Was everyone able to get the answers? We'll go through the process one more time. So this is the question. A 10-meter link is there over which a sender can transmit at a rate of 150 bits per second. So this is total bandwidth. So suppose there are 10 connections using the same transmission. So each of them will get a portion of that. So if there are 10, if we equally divide the 150 with 10, then each one will get only 15 bits per second in both directions. So suppose the packets containing data. So this is the size of the data bits and data packet, and control packet, that is acknowledgement or handshaking, they take 200 bits. So now we are considering that there are n parallel connections, and if in this case each and every one will get the total, that is 150 divided by n of the link bandwidth. Now considering the HTTP protocol, and suppose that each downloaded object is 100 kilobit, which is equal to 100 into 1000, 10 to the power 3. So again 100,000 or 1 lakh. So the initial object HTML, once downloaded, that will contain 10 reference objects from the same sender. So in this case, the main question was asking was, would parallel downloads via parallel instances of non-persistent HTTP make sense? Or is normal persistent HTTP, which also does use parallel, is it the same? Like, does it make any difference? So are there any significant gains or not? So that was the question. So we found that there are no significant gains. First, we mentioned all the values that were given, and then we calculated individually what each connection would equate to, and after adding all, we got the value. And similarly, we got for persistent HTTP connection as well. And since we have to calculate the TPE value, so we did it based on the speed of light and the length of the connection, that was 10 meters. And since it is such a small value, negligent, we just ignored it because it doesn't matter. And it is almost 10 to the power 6 magnitudes, 10 to the power 9 magnitudes smaller compared to the other values. So is there any doubt?
So cannot there be segmentation of the data packets since they are very large?
Yes, exactly. They can be done. But here the packet size was already defined to us as very huge. So I have a question for you, which you can try at home. Okay, same question. Just consider that the packet size is 500,000, 50,000 instead of 100,000. So there will be 2 packets for each object. So what will you do in such case? That I want you to work on after the class ends. And if you can, please send the answers.
Sir, am I audible?
Yes, you are audible.
Yeah, sir, can you explain the persistent HTTP case once again?
Okay, persistent HTTPS, right?
Yes, sir.
Okay. in persistent HTTPS, what we do is first, after we get the IP address, we first create a connection with the web server. So first we send a request and we get a response. We get an acknowledgement. So once the connection is created, all the interaction that happens between that specific web server and the user, that is the client system, happens within that single connection. We do not need to make any other connections after that. So what we do is after the connection is created, we get an HTML file which will reference other objects. So to get the HTML file, it will take some time, one RTT, whatever the RTT. Let's consider RTT0 as was in the first question. So once we get that HTML file will then reference multiple objects. That is, what are objects? Objects are images, text, or other such objects that we see on the web browser in our website. So each of those, if it is a non-persistent connection, so for each of those extra objects, we'll have to create a separate connection, which will take more time for each object. But if it is a persistent HTTP connection, the first initial connection is sufficient for us to obtain all these objects within the same connection itself. So what we'll do is we'll just read the HTML, we'll get it is referencing a certain object, we'll send a request for that object, and we'll get that object from the web server until all the objects are loaded in the client system.
Yes, sir.
Is that clear?
Initially we are making a request for the HTML file. That is the second bracket in the persistent HTTP case.
Yes.
And after the request, we have like 10 objects with us. So why can't we take 10 parallel connections for the 10 objects?
Yes, we can take parallel connections for 10 objects.
But
so after the HTML
in this
part,
case, we are not taking the parallel connections, right? So we are fetching one after the other. That's why 10 into the time
yes,
for each object.
that was the condition in the question. Let me show you the question. Okay. So what we are saying, parallel instances of non-persistent HTTP. Now persistent, it's not mentioned, but that is the case. Okay, there is some.
Like if we take parallel HTTP, then
Yes,
there might be a
there'll
significant
be
difference.
some gain. Yes, there'll be gains because you don't have to do some. There'll be some gain, but not very significant, I think.
Okay, sir. Thank you, sir.
Okay. Are there any other doubts? Okay, so we'll now move to the next question then. Okay, does anybody know what an overlay network is? Okay, suppose there is a network. Okay, the network can have nodes, that is end systems, servers, and it can have routers. An overlay network is a logical form of that network, which makes it easier to find smaller distances or smaller hops between the endpoints. It removes some certain aspects to make it a simpler version of the underlying network. Okay, so let's consider this question. Consider an overlay network with n active peers, with each pair of peers having an active TCP connection. So there is an active TCP connection between each peer, and there are n such active peers. Additionally, suppose that the connection passes through a total of m routers. How many nodes and edges are there in the corresponding overlay network? So what are edges? Edges are connections between the nodes. So if there is a single node, then it will have no edge. If there are two nodes, there is one connection between them. So there is one edge between them. So is this question clear?
Sir, if you don't mind, could you quickly just tell how do we construct an overlay network?
Okay, what we do is there are some rules, but first of all, we'll just ignore all the routers there are. We'll remove them from the network, and we'll take just the end systems, the servers and the clients. and then connect them with each other. Okay. So in this case, there are n active pairs, right? So each and every of them will be considered in the overlay network, but all of the m routers will be removed out from the overlay network. Does that make it clear?
Yes, sir. Thank you, sir.
Okay. So we'll move to the answers. First, number of nodes in edges. Let's say the overlay network is having n active peers. Each pair is having an active TCP connection. Also, the TCP connection passed through m router in total. This is all given in the question. So, total number of nodes in the overlay will be, first of all, the routers will not be considered because they are in the lower network, underlying network, and not the overlay network. So total number of active peers will be the total number of nodes in the overlay network, which is equal to n. Okay, very simple. So n. So now we have to calculate the number of edges. So what happens is, if there is a single node, it will have no edges. If there are two nodes, then one edge is required to connect those. There are three nodes, let's say a triangle in a triangular form. So three edges are required to connect these nodes. Have you guys done graph theory in maths?
Yes, sir.
Okay, so you know what a complete graph is, right?
Yes, sir.
Yes, sir.
Okay, so similarly, if there are n nodes, then 6 edges are required. A complete graph, because each node has to be connected to all the other remaining nodes. Okay. So suppose there are n nodes as seen in our network. So each will have to be connected to n minus 1 other nodes, right? So if we take the first node and see all the other nodes that are being connected, so for n nodes, all edges, each and every two nodes have at least one connection, as exactly one connection between them, direct connection. So can we write that as NC2? Are you guys aware with the?
Yes.
So let's do it in a simpler way. So first, what will happen is pick up any one node, and that will be connected to n minus 1. Now pick the next node, and excluding the first node that we took, that second node will be connected to n minus 2 nodes. Now unique nodes, that is. Then take the third one, that will be n minus 3, and so on until it will go to 1 and 0. Okay. So if we add all of that, we get the value of n into n minus 1 by 2. Okay, the answer is missing here. N into n minus 1 by 2. That is the total number of edges that will be there. Okay. Any doubt? Okay, since time is short, we'll move on. Okay, this is a very simple question. How many TCP connections are required for file transfer protocol?
Two.
And why do you think two connections are required?
Like one is for transferring data, one is for control.
Okay. Saurav.
Yes, ma'am. So that is the end of our questions for today. If you have any questions, you can contact us TAs or ma'am anytime. Thank you.
Okay, so thanks to Saurav and Pradeep for taking the class in such a nice manner. So I hope that you all understood the numericals. Okay, this is how, or this is the way questions are. I mean, I expect questions, and I expect also the answers to be given. Okay, in your papers when you give later on. All right. So please try and practice some questions. There, Kuros and Ross also has some numericals in its example sections, and you can also practice from other books which I have already mentioned in the references. Okay, Tannenbaum is also there. All right. So please go ahead, practice the questions. This is for your own understanding. And tomorrow's class will start with network layer. Okay, we'll again have one more class where we will have transport layer numericals also. Okay, so thank you all. See you tomorrow. Okay, thank you. Thanks, Pradeep and Saurav.
Thank you, ma'am.